I'm Gary Wagner, president of Ophir-Spiricon. We make laser measuring instruments. There are two major types of measurements one makes of a laser. The first being averaged or instantaneous power using a sensor and a meter. The second is spatial distribution of the power across the beam. Those are configured either using a camera-based system or a slit-based system. There are over 100 different heads and multiple configurations of both cameras and scanning slits. In this video, our sales engineers will teach you what you need to consider when choosing a beam profiling system.
There are several aspects in selecting the proper beam profiler.
4 things you need to look at are wavelength,
the power of your laser,
the size of your beam, how large is it?
And is the beam pulsed or continuous, and if it's pulsed, what the rep rate is?
If we know those 4 aspects of the laser, we can then determine the best profiling equipment for that application. There's a variety of lasers from UV to terahertz.
different sensors have a different response depending on the wavelength.
Wavelength then determines what sort of detectors we're going to use.
Visible sources will require silicon, for example, where ultraviolet would require a slightly different camera. Infrared and terahertz will certainly have its own type of camera system.
They have specific wavelength ranges in which they're most effective. So if you have something that's in the visible, you'd want to use the silicon. It has the best resolution, most sensitivity. If you're running out at telecom wavelengths 1550, an InGas or a phosphor-coated camera will work. A silicon will not. Or you could use a PyroCam. If you're looking at longer wavelengths, like many of the defense applications, you're out 2+ microns, you want to use the PyroCam because it has sensitivity all the way out into terahertz range.
With the nanoscan, we have a germanium detector which works from about 800 nanometers up to about 1800 nanometers, and that's right in the wavelength range for the telecom industry.
So it's very important to match up the application of the wavelength to the cameras.
A laser is basically photonic energy. It can tear things up. And in fact, it's used to weld, it's used to ablate, it's used to cut things.
A system for a 5 milliwatt laser is completely different to a system 100 watt laser, and this is completely different to a 1 kilowatt laser.
The power is important to know for several reasons. One, do I have enough power to use a pyro detector? Do I have to use a silicon or germanium detector?
Typically cameras are very sensitive, so you'll want to take into account the power. Usually you have to reduce. You'll pick off a small portion of the beam.
And if you have a high power in a very tiny space, that's the size of your laser. If we put too much power in a tiny space and you stick it directly on your sensor, you're going to blow a hole in it.
Lasers with too little power may require the beam to be expanded. Situations where the power is too great for the camera, we may have to introduce some beam splitters and filters.
Spot size will help you determine whether you need to add any additional optics or whether you can take the beam directly onto the sensor.
And you need to illuminate at least a certain number of pixels to get an accurate reading.
If you overfill the sensor, the detector, if your beam is much, much larger than that, then you're not going to get a proper profile. It doesn't matter what you do. You're just going to overfill it, and you're just going to see a solid thing. You're not going to get the edges. You're not going to get the information outside that you absolutely have to have.
Beams that are too large to clear the aperture or fit on the array will need to be reduced. Beams that are too small may have to be expanded.
Developing and providing the necessary optics to either reduce the beam to get the beam onto the array or to expand the beam so the beam is large enough on the array will allow us to get accurate measurements.
If the beam is very small, I would say under 50 microns perhaps, then one needs to use a scanning slit profiler. If it's larger than 50 microns, then CCD camera might work. If it's larger than 500 microns, then the pyrocam will work. In between that, InGas cameras will work for beams about 100 microns or more. So the size of the beam that you want to measure is going to determine which kinds of profilers you can use.
In the laser industry, there's typically two kinds of lasers. There's pulse lasers and there's CW lasers.
CW beams are continuous wave, and what it is it just continuously runs the whole time. The pulse beam strikes it at certain frequencies.
Cameras operate at typically a certain frame rate, and various cameras operate at high frame rates, others operate at very low frame rates. With a CW beam, it really doesn't matter. You can use any camera we've got, keeping in mind the other factors of the criteria needed. However, in a pulse laser, you have high energy levels for each pulse, and it's necessary then to be able to synchronize the camera with the laser itself.
Pulse beams are best measured with CCD, especially at lower rep rates. The lower the rep rate, typically the CCD is the better solution.
And if it's less than a kilohertz, then basically I'm looking at a camera system.
And so you can have Q switch, which are very, very fast, high power, high energy. You can have femtosecond pulses, which are very, very, very short.
Pulse systems may require an optical trigger or an external triggering.
If it's pulsing at a fairly high rate in the kilohertz, then it's quite possible to use the scanning slit.
But we have to know up front what you're using so we can optimally design a system for you. We've got good selection. We can select the proper one to fit your exact application.
From soft X-ray to terahertz, nanowatts to kilowatts, less than a micron to 3 meters, Spiricon and Photon beam profiling systems ensure success of every laser application, whether medical, military, industrial, or scientific. Call 866-755-5499 to discuss your laser application with a Spiricon sales engineer. Or visit us on the web. Ophir-Spiricon, the true measure of laser performance.